Hello, guys. Welcome back to my recording on some revision questions for the AWS Certified Solutions Architect Associate Exams, SAA C03. And please, if you're enjoying the video and you want to keep yourself in the loop for all the videos I'm going to upload in the future, please hit the subscribe button, hit the notification bell so that you don't miss any video. And as you can see, I'm doing my best to make the videos better and better, and I'm going to keep bringing you a lot of value. And yeah, at the end of the day, we all want to pass the exams and become AWS solution architects. So let us learn together. Leave some comments and let me know what you are thinking. Okay, so question number 25 says a company is designing an application. The application uses an AWS Lambda function to receive information through Amazon API gateway and store the information in an Amazon Aurora PostgreSQL database. Now, during the proof of concept stage, the company has to increase the Lambda quotas significantly to handle the high volumes of data that the company needs to load into the database. A solutions architect must recommend a new design to improve scalability and minimize the configuration effort. Which solution will meet these requirements? So the options are A, refactor the Lambda function code to Apache Tomcat code that runs on Amazon EC2 instances. Connect the database by using native Java database connectivity, that is JDBC drivers. B, change the platform from Aurora to Amazon DynamoD provision and DynamoDB accelerator DAX cluster. Use the DAX client SDK to point the existing DynamoDB API calls at the DAX cluster. C, set up two Lambda functions. Configure one function to receive the information, then configure the other function to load the information into the database. Integrate the Lambda functions by using Amazon Simple Notification Service, Amazon SNS. Then D, set up two Lambda functions. Configure one function to receive the information. Configure the other function to load the information into the database. Integrate the Lambda functions by using an Amazon Simple Queue service, Amazon SQSQ. Brilliant. So I'm going to pause the video and have a think about the question myself. Do same, and we'll come together and try to, figure out the answer together. Thank you. All right, so let us first of all try to understand the scenario. Okay, so question says that company is designing an application, okay, and the application uses AWS Lambda function. I believe what we know what AWS Lambda function is. It's a serverless compute service that lets you run code for virtually any type of application or backend service without provisioning or managing service. Okay, so you don't need to provision or manage any service. It's serverless. You're able to run code without any service, which is very cool. So this application is going to run code without service because they're going to use Amazon Lambda function, and they're going to receive information through the Amazon API gateway and to store the information in this database that is Amazon Aurora PostgreSQL database. Okay. Now, during the proof of concept stage, the company has to increase their Lambda quota significantly to handle the high volumes of data that the company needs to load into the database. Now, a solution architect comes in and says, okay, I can recommend a new design to improve scalability and minimize the configuration effort. So what solution, basically what we are being asked to do is, what solution do you think this solution architect is going to recommend that will best meet the requirements? Okay. All right, so as we know, for every question there are detractors. So what I love to do is try and get rid of the detractors, those that I believe will not be the answers, and so that I can focus on those which are can be the answer. If you look at A, it says refactor the Lambda function code to Apache Tomcat code that runs on Amazon EC2 instance. You don't need to understand all of these Apache Tomcat code and all of that. But basically, what A in summary is trying to say is that yes, when we refactor the Lambda function, yes, we know that Lambda is serverless and automatically will scale. But with the EC2 instance, it says when you refactor the Lambda function, it's going to run this Apache Tomcat code, and it's going to run on Amazon EC2 instance. And Amazon EC2 instances you have to create a load balancer, an application load balancer behind it, and auto scaling group, a lot of things. And you also have to connect the database to Java database connectivity drivers, and those do not necessarily improve performance. Okay, so we can forget about A. And if you look at B, you are going to do a lot of things to changes and DynamoDB accelerator use for cache, that is for read purpose, not for write. Okay, so we can forget about that. That's not what is meeting the requirements. And if you look at C, SNS, okay, this thing, SNS, Amazon Simple Notification Service, okay, is used to send notification, that is email, SMS, and all of that. But that's not what we really after. What we really after is for the company to increase the Lambda quotas significantly to handle high volumes of data. Okay, so what can we design for this to be done? All right. So if you look at D, it says set up Lambda functions, configure one function to receive the information, configure the other function to load the information into the database, integrate the Lambda functions by using Amazon Simple Queue Service. Okay, with SQS, we can scale application well by queuing the data. So SQS help us to scale the application by queuing the data. So it looks like the answer is going to be, D. Okay. It looks like the answer is going to be D, I believe. So let's reveal the solution. Let's see. Yeah, so 100% of the community voted for, voted for D as the answer. Yeah, so it makes sense. Let me know what you think. If you got a different answer, and you can leave the reason why you think your answer is correct in the chat. That would be brilliant. I'll have a look and see if I agree with you or not. But for me, it makes sense for me for D to be the answer. Okay. Move on to the next one. Okay, so we can move on to question number 26, I believe. Okay, so question 26 says, A company needs to review its AWS cloud deployment to ensure that its Amazon S3 buckets do not have unauthorized configuration changes. What should a solutions architect do to accomplish this goal? So, A, turn on AWS config with the appropriate rules. B, turn on AWS trusted advisor with the appropriate checks. C, turn on Amazon inspector with the appropriate assessment template. And D, turn on Amazon S3 server access login. Then configure Amazon event bridge. That is Amazon CloudWatch event. It used to be called Amazon CloudWatch events. Okay. So what I'm going to do from this point on is I'm going to read a lot of questions. I read, we've looked at 25. I'm going to read 26, 27 to the end of this page. Then in the next video, we are going to review the answers. Okay, yeah, I'm looking for the stop thing that will let me let us pause and look at it, but I don't know. I can't find it on the screen, to be honest. I'm still figuring out how to use a lot of software for the recording, and sometimes when you use the desktop app, it gives you a lot of difficulty navigating it, but don't worry. We're just going to read through all the other questions, and you yourself, whilst you're watching the video, you can pause it and try to figure out the answer. And later in the video, or in the next video, we will go back and discuss all the questions that we've not yet discussed. Okay, brilliant. So let's go to question number 27. Question number 27 says, okay, we'll scroll. Okay, so question number 27. A company is launching a new application and will display application metrics on an Amazon CloudWatch dashboard. The company's product manager needs to access this dashboard periodically. The product manager does not have an AWS account. A solutions architect must provide access to the product manager by following the principle of least privilege. Which solution will meet these requirements? A, share the dashboard from the CloudWatch console. Enter the product manager's email address and complete the sharing steps. Provide a shareable link for the dashboard to the product manager. B, create an IAM user specifically for the product manager. Attach the CloudWatch read-only access AWS managed policy to the user. Share the new login credentials with the product manager. Share the browser URL of the correct dashboard with the product manager. C, create an IAM user for the company's employees. Attach the view-only access AWS managed policy to the IAM user. Share the new login credentials with the product manager. Ask the product manager to navigate to the CloudWatch console and locate the dashboard by name in the dashboards section. And D, deploy a Bastion server in a public subnet. When the product manager requires access to the dashboard, start the server and share the RDP credentials. On the Bastion server, ensure that the browser is configured to open the dashboard URL with cached AWS credentials that have appropriate permissions to view the dashboard. Brilliant. So as I said, you can pause, have a think about it, and note down your answer, and we will review it together. So I'm going to read question number 28.
Alert from calendar. Kaggle's office hours project support.
Question number 28. A company is migrating applications to AWS. The applications are deployed in different accounts. The company manages the accounts centrally by using AWS organizations. The company's security team needs a single sign-on SSO solution across all the company's accounts. The company must continue managing the users and groups in its on-premises self-managed Microsoft Active Directory. Which solution will meet these requirements? So A, enable AWS single sign-on, AWS SSO from the AWS SSO console. Create a one-way forest trust for a one-way domain trust to connect the company's self-managed Microsoft Active Directory with AWS SSO by using AWS Directory Service for Microsoft Active Directory. B, enable AWS single sign-on, AWS SSO from the AWS SSO console. Create a two-way forest trust to connect the company's self-managed Microsoft Active Directory with AWS SSO by using AWS Directory Service for Microsoft Active Directory. C, use AWS Directory Service. Create a two-way trust relationship with the company's self-managed Microsoft Active Directory. D, deploy an identity provider IDP on premises. Enable AWS single sign-on, AWS SSO from the AWS SSO console. So that is question number 28. Let's move on. Question number 29. A company provides a voice over internet protocol VoIP service that uses UDP connections. The service consists of Amazon EC2 instances that run in an auto-scaling group. The company has deployments across multiple AWS regions. The company needs to route users to the region with the lowest latency. The company also needs automated failover between regions. Which solution will meet these requirements? A, deploy a network load balancer, an NLB, and an associate target group. Associate the target group with the auto-scaling group. Use the NLB as an AWS Global Accelerator endpoint in each region. B, deploy an application load balancer, ALB, and an associate target group. Associate the target group with the auto-scaling group. Use the ALB as an AWS Global Accelerator endpoint in each region. C, deploy a network load balancer and an estimated target group. Associate the target group with the auto-scaling group. Create an Amazon Route 53 latency record that points to aliases for each NLB. Create an Amazon CloudFront distribution that uses the latency record as an origin. B, deploy an application load balancer and an associate target group. Associate the target group with the auto-scaling group. Create an Amazon Route 53 weighted record that points to the aliases for each ALB. Deploy an Amazon CloudFront distribution that uses the weighted record as an origin. Okay, we'll probably read the last one. Question number 30. A development team runs monthly resource-intensive tests on its general-purpose Amazon RDS for MySQL DB instance with performance insights enabled. The testing lasts for 48 hours once a month and is the only process that uses the database. The team wants to reduce the cost of running the test without reducing the compute and memory attributes of the DB instance. Which solution meets these requirements most cost effectively? A, stop the DB instance when tests are completed. Restart the DB instance when required. B, use an auto-scaling policy with the DB instance to automatically scale when tests are completed. C, create a snapshot when tests are completed. Terminate the DB instance and store the snapshot when required. D, modify the DB instance to a low capacity instance when tests are completed. Modify the DB instance again when required. Okay. All right. So we will probably pause the video at this point and give yourself some time and try and get the answers. And and in the next recording, we will see if we can discuss the answers. So I'll see you in the next recording. Ciao, bye.